Hi, my name is David Cardona. I designed the STCV-Synth in collaboration with Robert Fisher as our final project for wearable devices and computer vision at Harvard Extension School. To launch the STCV-Synth at the root directory, you can run python main.py. This is going to prompt you to initialize the synthesizer engine. You can either initialize the synthesizer defaults, which have been assigned for you, or you can choose your own custom settings. I'm going to choose custom settings. First thing we'll be asked is to choose a tonal center. A tonal center is one of the notes of a 12-tone system and the corresponding frequency of that note. In this case, the tonal center is going to be the note to which every other note in a scale relates to. I am going to choose C. Now we're going to be asked for a multiplier. The base is going to be the frequency of that tonal center that we picked. That means 130.81 Hertz. Then a multiplier is going to be applied to that frequency in order for us to be able to either lower or increase the lowest frequency that is available for our synthesizer. The option is here on the left, the applied multiplier is here in the center, and each one of them has a maximum octave range applied to them. This is so that as your lowest available frequency goes higher, you don't start reaching into a range where notes start feeling more like harmonics and less like fundamental notes. I am going to pick a multiplier of 1, meaning that I am going to be using, for my performance, a lowest frequency of 130.81 Hertz. You will see that with the computer vision controller, I can update this. Then we will be asked what scale we want to use. Scales are implemented in a data-driven fashion. What that means is that they are indices that range from 0 to 11, and they determine what notes are going to be available and how those notes relate in terms of intervals to our selected tonal center. I am going to pick a major scale, and the name for a major scale is Ionian in the Greek modes. Then we're going to be asked what the span of our scale is going to be. This means how many octaves is going to cover. I want my whole performance to encompass 3 octaves of the major scale. Then we're going to be asked what the beats per minute is going to be. I'm going to tell it to be 120 beats per minute. And then we're going to be asked what musical note or subdivision is going to be applied to that beats per minute. Whole notes is going to extend it and make it longer. Half notes will do the same. Quarter notes, you will notice, is the same as beats per minute because that's the quarter note rate that we chose. So the multiplier is effectively going to be 1, maintaining this as our rate. I am going to choose 16th notes so that there are 4 notes in the time duration that there would normally be only 1 quarter note. Then we're going to get a confirmation of our settings. Following this, we're going to be asked to initialize the controllers. We will be asked whether we want a sensor tile controller. I am going to say yes. The Bleak library will scan for available Bluetooth devices. Here it confirms that it found a sensor tile via the name of the firmware. It will expose what the UUID address of my sensor tile is. It initializes a connection and it connects to my sensor tile. Then we will be asked whether we want to use the computer vision controller. I will say yes. Then there is a debug mode that is able to display the frames per second on screen. I do want to display frames per second. Then our performance will start. I will switch the view to Python so you can see me. Hi. This is the sensor tile. You will notice that as I move it, the polar angle of the sensor tile is going to control the filter. If I move it and shake it, the magnitude of acceleration of the sensor tile is going to determine various aspects of the envelope generator, mostly affecting the loudness. And then the azimuth value, which can be felt as I move it and as I rotate it and move it around the space, will control the reverberation of the space. I'm going to leave it at a small tilt so that I can demonstrate the computer vision controller. The computer vision controller is operated by detecting the index, the tip of the index fingers. It can detect either one of your indices. Those indices can be used to interact with the different GUI elements that we have designed. So I can change the octave range. I can shorten it. That means that the notes won't go as high. But I can also lower the octave bass. That means we will have access to lower notes. We can also extend the range. And you will notice that as I bring up the octave bass, it needs to detect my finger, has to do with the light. As I bring up the octave bass, the octave range will be reduced so that we're not reaching into a range that is not musical. As I bring this lower, we can bring the octave range back up. Now we can change the subdivisions. We can make it a little bit shorter, or we can maintain them a little bit faster. BPM can be controlled via this slider. For the time being, BPM while running the computer vision will suffer some lag. This is because we have no multiprocessing enabled at this time. Once multiprocessing is implemented, we hope for computer vision to be fully independent from the musical portion, meaning that there won't be any latency in the audio nor when updating the image. Additional settings can be accessed by triggering this button right here. This will allow us to pick scales. The different scales can be accessed through these buttons, and you can hear them as I rotate the sensor tile. These two menus are for future implementations. We are planning to use the left and right selector to determine in what hand the user is wearing the sensor tile. This is useful for performances so that one hand can be in charge of taking care of the computer vision component, whereas the other one can move freely, avoiding double detection of your index fingers. Then pulse sustain hasn't been implemented, but we wish to implement a sustain mode where notes are not going to be pulsing at a given rate, but rather are going to be triggered by the user. And then all these motions are more likely to be controlling things like pitch and the filter and etc. This has been the STCV-Synth. Thank you very much for watching.